Some series integral. Some series and integral calculus. Lot of people are watching this session. Some series and integral calculus. This is what I am saying. Lot of people are watching some series and integral calculus. Can we compute sum and series through integral calculus? No one would have tried it, I'm sure about it. Because generally, people consider integration as secondary item. Primary item in calculus is differentiation, differential equations. At the end, people would find a topic like integral calculus because calculus starts from differentiation. This is what generally people believe so. Mathematics starts from addition. Mathematics does not start from subtraction. Subtraction, if someone proceeds, then it will lead to division and then it may lead to differential equation differentiation. Whereas summation would lead to multiplication and then multiplication would lead to integral calculus. This exactly proves that integral calculus came first and then differential calculus came afterwards. So integral calculus can do a lot and lot of magic. I would rather say integration is 100% and 0% is differential calculus. Okay, what I mean is addition is everything. There is nothing called subtraction. Subtraction is addition only in reverse direction. That's same way, 2 minus 3 is a wrong statement. 2 minus 3 is a wrong statement. What is the correct statement? Is 2 plus and then in bracket minus 3. Actually, it is plus only 2 plus and another item that with which it will get plus. That item is minus 3. 2, 2 plus 2. 2 is plus 2 minus plus 3. This is not true. 2 plus 2 plus minus 3. Plus 2 is one entity and minus 3 is another entity and they are added. Minus means reverse direction. If integration happens in reverse manner, then it becomes differential calculus. Can you prove it? Yes, certainly we will prove it. Okay. If someone has a velocity graph, integration calculates area. Integration calculates area. If someone has velocity graph called fx, then integration of fx will give gx and the gx is the displacement and displacement itself will be a graph. It is algebra. It may be algebra, may not be a constant. Fx is a velocity graph. Integration of fx may come as gx, which is another algebra, and gx another algebra, and gx is displacement function displacement function. If I talk in reverse manner, if I say anti-integral of gx anti-integral of gx, if I do gx in reverse fashion, some anti-integral, then it will we can get back the fx. Integration of fx equal to gx. Anti-integration of gx will bring fx back, and this is what generally people denote it through differentiation. Okay, integration means calculation of area. If I have fx into width, fx is height into width, fx into width gives gx. If I divide gx with the width, I can get back fx. Okay, means width is generally it is time. If fx is velocity, velocity into time is displacement. If I divide displacement back with the time, I'll get fx. If I do anti-integral of gx, I'll get back fx. That's it. Now someone can say anti-integral means differentiation. How I can get back? If I have a displacement graph, if I have a displacement graph and I'm able to find the slope at any point, makes sense? If this is x-axis and this is a displacement graph, at any point, if I'm trying to calculate the slope or tangent at any point. The tangent can come in algebra, and that algebra is fx, for which this is the gx. Makes sense? Anyway, so integration is the main concept. We will take another example. What is 2 to the power minus 2? 2 to the power minus 2. I have a number. I have a number 2 to the power minus 2. Next number is 2 to the power minus 4. Next number is 2 to the power minus 6. 2 to the power minus 8. Like so. What is like so? What do you mean by like so? Okay, if you are not happy, 2 to the power minus 200. You tell me. 2 to the power minus 2, 2 to the power minus 4, 2 to the power minus 6, 2 to the power minus 8, 2 to the power minus 10, 2 to the power minus 200. Okay, this is a series. This is a new series. Can you collect some, can you compute, can you calculate summation of it? Can someone can calculate 2 to the power minus 2, 2 to the power minus 4, 2 to the power minus 6, 2 to the power minus 8, 2 to the power minus 2 plus 2 to the power minus 4 plus 2 to the power minus 8, and so up to 2 to the power minus 200. Someone would say, why don't you say 2 to the power minus 2 to the power minus? But I did not say minus n. There is a reason behind it. Okay, someone can say up to infinite. All right. Can someone find it? Okay, let's say there are n number of terms. If I say 2 to the power minus 2, 2 to the power minus 4, 2 to the power minus 6, the number of terms are 3. Number of terms are 3. Consider there are n number of terms. There are n number of terms. In that sense, if someone need to calculate the computation of n number of terms, then how it can be? Okay, let's divide this n number of terms into part by part. First part is 2 to the power minus 2. Second part is 2 to the power minus 4. Third part is 2 to the power minus 6, like so. Can I now write all part as same? Because in notebook I am writing 2 to the power minus 2 plus 2 to the power minus 4 plus 2 to the power minus 6 plus 2 to the power minus 8 plus. People can go through algebra. There is a formula in algebra. One, I'm sorry, a to the power a. I'm sorry. Hop. A to the power 0 plus a to the power 1 plus a to the power 2 plus a to the power 3 plus a to the power n. If someone does this, then that will be a to the power n plus 1 come down minus 1 divided by a minus 1. People know this formula, but this formula, how much it will work here, I don't know, because it is 2 to the power minus 2. If I say 2 to the power minus 2 is actually 1 by 2 to the power 2 plus 1 by 2 to the power 4, but it is not continuous though. It should be 2 to the power minus 2, 2 to the power minus 3, 2 to the power minus 4, like so. But it is not like so. It is different. Okay, if someone is going through algebraic proof, then he has to remember this proof also. Along thousands of proofs in sum and series, he has to remember this proof also separately. I can take anything and I can solve through integral calculus, and that is the concept behind this discussion. Can we solve anything? Can we solve anything through integral calculus? Okay, so we will try now. So how I can write all the component if I divide n terms into part by part, then each part how I can write in same manner. Then in that manner, I can rewrite it as 2 to the power 2x, 2 to the power, I'm sorry, 2 to the power minus 2x plus 2 to the power minus 2x plus 2 to the power minus 2x plus all are same now. I have n components in same terminology. 2 to the power minus 2x. Thank you very much. 2 to the power minus 2x. This is what you are saying. Yeah, this is what we are saying. 2 to the power minus 2x. What is x? X is variable. And x starts from 1 and it will go up till n. This means that sigma x equal to 1 to n. Sigma x equal to 1 to n function over x. Okay, sigma x equal to 1 to n function over x, where function over x is 2 to the power minus 2x. You mean 2 to the power minus 2x is 1? Yeah, 2 to the power minus 2 plus 2 to the power minus 4 plus 2 to the power minus 6 plus 2 to the power minus 8, like so. Yeah, yeah, like that. Where x goes 1, 2, 3, 4 up to n. Makes sense? So at the end, it will be 2 to the power minus 2n. Now it is all right. Okay, n term we have to add in this manner. Okay, if I go with repeated addition like 3 plus 3 plus 3 is 3 into 3, 3 into x where x is 3, or 3 dx limit 0 to n. Similarly, if I do here, then it will become 2 to the power minus 2x into x term, where x is n, 2 to the power minus 2x dx 0 to n. What is integration of 2 to the power minus 2x? If it is 2 to the power x, then integration is 2 to the power x by logarithm natural log of 2. If it is 2 to the power minus 2x, then integration will be 2 to the power minus 2x 2x by natural log of 2 and whole multiplied by minus 2. Makes sense? How it came? Okay, we can use differentiation for simplicity. What is differentiation of 2 to the power minus 2x? We will differentiate by 2 minus 2x. 2 to the power minus 2x differentiated with minus 2x, it will result in logarithmic of 2, 2 to the power minus 2x only, and then differentiation by chain rule. Differentiation of minus 2x with x will result in minus 2. Net will be minus 2 into logarithmic of 2 into 2 to the power minus 2x. Integration will be just opposite. So differentiation is anti-integral only. So it will become 2 to the power minus 2x divided by minus 2 into logarithmic of 2. This will be the integration. Now from 0 to n, if I place n, then it will be 2 to the power minus 2n. 2 to the power minus 2n. 0, it will be 1. 2 to the power minus 2n minus 1 divided by minus 2 into logarithmic of 2, or 1 minus 2 to the power minus 2 divided by 2 into logarithmic of 2. Okay, 2 into logarithmic of 2 will become logarithmic of base e of 4 only. Anyway, whatsoever. This is the answer, and this may not be perfect. Okay, let's say n tends to infinity in the infinite series, then 2 to the power minus 2n will become 0. Only 1 will remain in the numerator. 1 by logarithmic of base 4, base e, logarithmic of 4. That will come, I believe, 1 point, it will come as 1.4. 1 by 1.4. That will be the result here. 1 by 1.4, I think so. I think so. Okay, 1 by 1.4 or something like that. Okay, someone would say this is not perfect. This is not correct. Okay, so but this gives a intuition that this is how it should be. Okay, it will be a constant, and it will be like 1 by 2 into logarithmic of 2. Okay, something like that. Okay, someone would say, why I should follow your procedure when I know that through algebra I can solve it perfectly. Okay, we will do it perfectly through integral calculus. That is called successive approximation. Successive approximation deal with how to convert a discrete function into a continuous function, because integration works in continuous function. Integration does not work in discrete function, unfortunately. Integration works in continuous function. Can I convert this discrete function? What is your discrete function? Discrete function is 2 to the power minus 2x summation sigma x equal to 1 to n function over x, sigma x equal to 1 to n function over x, function over x. Okay, means 2 to function over x is 2 to the power minus 2x. That is function over x. If this is function over x, then actually if I break it, then it will become function over x plus function over x plus function over x n times, where function over x is e to the power minus 2x. X will go 1, 2, 3, 4. E to the power, I'm sorry, 2 to the power minus 2 plus 2 to the power minus 4 plus 2 to the power minus 6 and so on. So summation x equal to 1 to n function over x. This is a discrete summation. If I want to use integral calculus, fx we cannot use. Many times we have demonstrated it. Discrete function cannot be used in integral calculus. Integral calculus works with continuous function. So if okay, if this is x-axis, then this is function over x-axis. Then I have a formula called 2 to the power minus 2x. So when x is 1, then I have a height called 2 to the power minus 2. When x is 2, then I have a height of 2 to the power minus 4. When x equal to 3, I have a height of 2 to the power minus 6, like so. It is decreasing. Okay. What is addition of all the heights? That is the question. Then we have, okay, what is your function? So function is like this. This is 2 to the power minus 2x. It is decreasing function. Okay, or it can be said like this, decreasing function. Okay, if I say this is 2 to the power minus 2x is a discrete function. Why we are saying discrete function? Because it is not continuous. We cannot take, if I say fx equal to 2 to the power minus 2x, this fx cannot be estimated at x equal to 1.1, 2.2. It will have value only at x equal to 1, 2, 3, 4, 5, 6, 7, 8, something like that. In that manner, what will be a kind of continuous function related to it? What do you mean by continuous function? What I mean with a continuous function is x fx, that is x equal to fx, that is equal to 2 to the power minus 2x, is sampled at x equal to 1, 2, 3, 4. If I take all the top point of this verticals, then I can connect and that function is called fx. Fx is sampled at x equal to 1, x equal to 2. In between there is a area subsection. If this area subsection, if it goes up and it hits another function, that is a continuous function, and its name is gx. Gx is another function and it is continuous, and we have to find what is gx. X, between x equal to 1 and 2, there is a subsection that go and hit gx. Means I can have n number of subsections when I have n number of vertical. If I have 3 vertical at x equal to 1, that is 2 to the power minus 2, x equal to 2, x 2 to the power minus 4, x equal to 3, 2 to the power minus 6. There are 3 verticals. Accordingly, there will be 3 sub area. If I take right, there I can take any side area. If I take right hand side area, then 2 to 3, x equal to 1 to 2, there is 1 sub area. X equal to 2 to 3, there is 1 sub area. And x equal to 3 to 4, there is another sub area. There are 3 sub area belonging to 3 verticals. If I add all 3 sub area, then we are calculating the integration of gx from x equal to 1 to 3 plus 1, where end is vertical is 3, at 3 it is end, but we are calculating 3 to 4. Area between 3 to 4 correspond to vertical at 3. Area between 2 and 3 correspond to vertical at 2, and area between 1 and 2 correspond to vertical at 1, x equal to 1. Okay, we have 3 area. What I am trying to say is summation x equal to 1 to n fx is same as integration 1 to 2 gx dx plus 2 to 3 gx dx plus 3 to 4 gx dx plus n to n plus 1. That is a big thing. N to n plus 1 gx dx. Okay, in that manner, I can rewrite full as limit 1 to n plus 1 gx dx equal to summation sigma x equal to 1 to n. Here it is 1 to n plus 1. Here 1 to n fx. Okay, what do you mean? The way you are saying, if I take any x equal to x, then I have a vertical of 2 to the power minus 2x, that is fx. Yeah, true. That will be area of right hand side between x to x plus 1 going and hitting gx the way you are saying. Yeah, because summation of fx at x equal to 1 to n is fx at x equal to 1 plus fx at x equal to 2 plus fx at x equal to 3, same and at the end fx at x equal to n additions are there. They are same as 1 to 2 gx dx plus 2 to 3 gx dx plus n to n plus 1 gx dx. If I take any fx at x equal to x, it will be same as x to x plus 1 dx dx, means 2 to the power minus fx equal to fx, just fx equal to x x plus 1 gx dx, means it will be like 2 to the power minus 2x equal to gx dx from x to x plus 1. I mean fx equal to gx dx, dx equal to dfx by dx. Okay, fx is 2 to the power minus 2x, dfx by dx will be minus 2 into logarithmic of 2, 2 to the power minus 2x. We will try gx with this only. Minus 2 logarithmic of 2, 2 to the power minus 2x dx from x to x plus 1. His integration will be exactly opposite and minus 2 logarithmic of 2 will go away. Only thing that will remain is a to the power 2 to the power minus 2x from x to x plus 1. 2 to the power minus 2 x plus 1 minus 2 to the power minus 2x. 2 to the power minus 2x I can take as a common item. So 2 to the power minus 2x and in bracket 2 to the power minus 2 minus 1. 2 to the power minus 2 is 1 by 4 only. 1 by 4 minus 1 will be minus 3 by 4. So it will come as minus 3 by 4, 2 to the power minus 2x. What is wanted? What we want? We want 2 to the power minus 2x. But we are getting minus 3 by 4, 2 to the power minus 2x. Means minus 3 by 4 is extra. Successive approximation. We will approximate. So whatever we had taken, I have to multiply it by minus 4 by 3 so that it will come to 2 to the power minus 2x. We will start again. Minus 2 logarithmic of a into minus 4 by 3, 2 to the power minus 2x is gx from x to x plus 1. If I compute say so, then it will become whatever we have taken as constant, it will be outside. Integration of a to the power minus 2x will be a to the power minus 2x by minus 2 into logarithmic of 2. They will cut each other and minus 4 by 3 will remain. Minus 4 by 3 will remain, and then a to the power minus 2x x to x plus 1, then it will come as same thing, a to the power minus 2x into minus 3 by 4. They will cut each other and at the end we will have a to the power minus 2x. Wow, we get, I'm sorry, 2 to the power minus 2x, both are same. Here also if fx is 2 to the power minus 2x and gx is 2 to the power minus 2x. I'm sorry, gx dx x to x plus 1, the end result. Means we have found the continuous function. Means if I have a gx that is minus 4 by 3 or minus 2 logarithmic of 2 into minus 4 by 3 into 2 to the power minus 2x. If this is the gx, this is the equation of gx, then gx dx full area from 1 to n plus 1 will be same as addition of n vertical. So we have found gx and we can directly jump into integral calculus. Limit 1 to n plus 1, 2 to the power minus 2x, okay, where the numerical factor outside is minus 3 by, I'm sorry, minus 2 logarithmic of 2 into minus 4 by 3, that is we will keep outside. Integration of 2 to the power minus 2x dx is from 1 to n plus 1. Its integration will come as 2 to the power minus 2x by minus 2 logarithmic of 2. So they will cut each other and minus 4 by 3 will remain outside. Okay, and here What we achieved after integration is 2 to the power minus 2x1. Limit is 1 to n plus 1. N plus 1, if I set, it will become 2 to the power minus 2 and x will become n plus 1. So it will become 2 to the power minus 2n into 2 to the power minus 2 minus then a to the power minus, sorry, 2 to the power minus 2x. If I set 1, 2 to the power minus 2. Okay, it looks promising. So what we are getting, 2 to the power minus 2n into 2 to the power minus 2 minus 2 to the power minus 2. So 2 to the power minus 2 I can take outside. 2 to the power minus 2. 2 to the power 2n minus 1 outside minus 4 by 3. So minus, if I settle down, it will become 4 by 3. 4 by 3 into 2 to the power minus 2 and in bracket 1 minus 2 to the power minus 2n. This is what the solution. Okay, anyway, 4 by 3 into 2 to the power minus 2. 2 to the power minus 2 will become 1 by 4. 4 will go away. 1 by 3. 1 by 3 into, in bracket, 1 minus 2 to the power minus 2n. That is the net summation. Okay, now what was the actual question? 2 to the power minus 2 plus 2 to the power minus 4 plus 2 to the power minus 6 plus 2 to the power minus 200 means minus 200 equal to minus 200 is equal to minus 2n. Okay, minus minus go away, n equal to 100. So we will apply now. 1 by 3, 1 minus 2 to the power 2 into 100 minus 200. That is the solution. It will be that much. 1 by 3 and in bracket 1 minus 2 to the power minus 200. 1 by 2 to the power 200. Whatever it is. If n tends to infinity, then that term will go away. 2 to the power minus 2n. Only 1 will remain in the bracket. 1 into 1 by 3. 1 by 3 is the solution. Now we will try one more time, probably in the next section, or someone can take it as an assignment. What about if I take less left side area? If x is 1, then first sub area is from 0 to 1, 1 to 2, 2 to 3, last will be n minus 1 to n. Means fx equal to limit x minus 1 to x f gx dx. End result will be 0 to n gx dx. Here we have taken 1 to n plus 1. There it will be 0 to n gx dx. Or someone can take in between. If this x equal to 1, then sub area we will take minus, 1 minus half and 1 plus half. The vertical will come in between. Okay, this sub area also we can take. Make sure that sub area width is 1 because sampling is happening every 1, x equal to 1 2 3 4. So width of sub area width will be 1. Either I take x to x plus 1 or x minus 1 to x, or here we will take x minus half to x plus half, and at the end we will take limit as 1 minus half to n plus half dx we have to find out. Amazing, mind blowing. These many examples we are taking so that limit will be clear to people. Limit is the main thing. If limit is understandable, then just see that there is only one way I have found, and I am calculating all the possible sum and series. Amazing, mind blowing. There are many sum series where the answer comes in approximation, Laplace constant, then a Schrodinger constant, then this constant, that constant. Student is hitting his head in the wall. What we can do now with so many constants? Nothing is required. Just go with the integral calculus. If it is coming as cumbersome, then you can break. Someone can break through the Sir-Taylor series or Sir-Maclaurin series, and then start again with the successive approximation and find out the nearest one gx, and then 1 to n plus 1 or 0 to n or whatsoever. That we will see other part, and then we will see more in some series. Amazing, mind blowing, not available in any of the book. Anyone can try. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. 60610 is the telephone number. +91 is the India country code.